Unlike every other planet in our solar system, Earth's surface is 70% liquid water, which, while useful for life, is also kind of weird, because everything we know about how and when our planet formed says Earth's surface should be bone dry. The story goes like this. Our solar system formed from the collapse of a large cloud of dust and gas. The dense blob of gas at the center ignited to form the sun, which as a young, unstable star, unleashed a fierce solar wind. Over time, this stream of charged particles pushed the remaining gas cloud farther and farther out, leaving only solid particles behind to clump together into rocks, planetesimals, and finally, the rocky planets of the inner solar system that we know today. And here's the problem. Water, in the form of ice, couldn't have been one of the solid particles that stuck around to form our planet, because the early inner solar system was far too hot for frozen water, and any water vapor would have been blasted away by the solar wind. So if Earth didn't start off with water, how did we end up with such splendid oceans? We know H2O wasn't manufactured here over the eons, because natural processes like combustion, breathing, and photosynthesis create and destroy roughly equal amounts of water. And either way, the amounts in question are so minuscule that they can't account for the abundance of water on the planet. Since Earth's water was neither part of the original package nor manufactured here, it must have flown in from far away, on meteoroids or comets or other bodies originating in the outer solar system where they were far enough from the sun for frozen water to survive. The dirty ice balls we call comets are a logical candidate for the source of our water, but were ruled out when we discovered that they were far richer in heavy hydrogen than Earth water. Heavy hydrogen has a neutron as well as a proton in its nucleus, and for every million hydrogen atoms in Earth water, about 150 are heavy ones, while typical comet water has twice that many. These mismatched chemical signatures suggest that Earth's water couldn't have arrived on comets. It turns out that the most likely source for Earth's water is a type of meteorite called a carbonaceous chondrite. Chondrite is just the name given to the class of stony meteoroids that most commonly strike the Earth. But only the carbonaceous chondrites contain water, as well as lots of carbon if you couldn't tell from their name. They have water in them because they formed out beyond the sun's frost line, and what's more, their water has levels of heavy hydrogen similar to that of Earth water, strongly suggesting that these Earth crashers are the source of our ice caps, clouds, rivers, and oceans. And thus the water that turned our planet into a blue marble came quite literally out of the blue. This episode of Minute Earth is supported in part by Tab for a Cause, one of our subscribers on Subbable, and also a browser extension that donates money to charity each time you open a new tab in your web browser. And it doesn't cost you a thing. Click the link in the description to start raising money for Water.org, Human Rights Watch, Save the Children, and more.